Welcome everyone. We are today discussing about types of engines and thermodynamic cycles. There are mainly four types of engines: two-stroke engine, four-stroke engine, petrol engine, and diesel engine. And after their cycles are Carnot cycle, Otto cycle, diesel cycle, and Rankine cycle. Now, first we see two-stroke engine. In this, on 31st December 1879, German inventor Carl Benz produced a two-stroke gas engine for which he received a patent in 1880 in Germany. And at a two-stroke engine is type of internal combustion engine that completes a power cycle with two strokes, which means up and down movements of piston during one power cycle, this power cycle being completed in one revolution of crankshaft. In two-stroke engine, the end of the combustion stroke and the beginning of the compression stroke happen simultaneously. Means exhaust and inlet happens at same time. Now the application of the two-stroke engine. Two-stroke engine, gasoline engine are preferred when mechanical simplicity, lightweight, high power weight ratio are design priorities. And in two-stroke engine, the process of converting fuel into motion is accomplished during one up and down movement. Two strokes of the piston during one crankshaft revolution. During compression stroke, during compression stroke, the piston rises, pulls a mixture of air, fuel, and oil into crankcase, pulls a mixture through an intake valve. At the same time, an air, fuel, or oil mixtures compressed in the combustion chamber. And during about power stroke, combustion retracts the piston, which closes intake valve and pulls more air, fuel, oil mixture into combustion chamber. At same time, exhaust is expelled from the combustion chamber through an exhaust port. Now, four-stroke engine. A four-stroke engine, also four cycles, engine in internal combustion engine in which the piston completes four-stroke while turning the crankshaft. Stroke refers to the full travel of the piston along the cylinder in either direction. The first four separate strokes are termed as index stroke, then after combustion stroke and power stroke, combustion stroke. We say combustion stroke as a power stroke, and after exhaust stroke. About four stroke. Now, at index stroke, what happens in intake stroke? Here, also known as induction or suction. This stroke of the piston being top dead centers and end at bottom dead center. In this stroke, the intake valve must be in open position while the piston pulls an air fuel mixture into cylinder by producing a partial vacuum in the cylinder through its downward motion. Now about compression stroke. This stroke being to VDC or just at the end of the suction stroke. At the ends at TDC, in this stroke, the piston compresses the air fuel. This is air compress the air fuel mixture in preparation for ignition during the power stroke. Both intake and exhaust valve are closed during this stage. After a power stroke means combustion, also known as a power or ignition. This is start of the second revolution of the four-stroke cycle. At this point, the crankshaft has completed a full 360-degree revolution while the piston at TDC. Now, exhaust. Exhaust, also known as outlet. During the exhaust stroke, the piston once again returns BDC to TDC, where the exhaust valve is open. This action explains the spent air fuel mixture through the exhaust port. Now, petrol engine. Uh, Petrol engines are internal combustion engines which have spark ignition and run on the relatively volatile fuels such as petrol. And in these engines, air and fuel are generally mixed post compression. Means uh, uh, air and fuel are mixed before compression. Uh, Petrol engines work on Otto cycle, which consists to isochloric process to isotropic process. Uh, in petrol engines, air and petrol are usually mixed at a carburetor before being introduced to cylinder. Uh, Once the air and petrol are compressed, the fuel is ignited via electric plug. Diesel engine. The diesel engine also an internal combustion engine, which is also known as compression ignition and ignition engine. It is named after Rudolf Diesel. That means Rudolf Diesel are making this engine. In this engine, the fuel is injected into combustion chamber and is then ignited by the high temperature of the air in the chamber. The high temperature of the air in the cylinder is due to adiabatic compression. These engines only compress the air and not the fuel. When injected into combustion chamber, the diesel fuel undergoes spontaneous ignition. This engine works on diesel cycle, which consists of constant pressure process, a constant volume process, and isotropic process. Now, we are discussing about thermodynamic cycles. First, Carnot cycle. The Carnot cycle is the most efficient power and composed of four totally reversible processes. In first, process 1 to 2. This is process 1 to 2. Now, isothermal heat transfer and heat supply. It is supplied at constant temperature. Uh, and now process 2 3. Isotropic expansion. Air is expanded isotropically from high pressure and temperature to low pressure and temperature. Process 3 and 4. Isothermal heat transfer. Heat is rejected at constant temperature. Process 4 and 1. Last 4 and 1. Isotropic compression. The air compress isotropically to high pressure and temperature. Stop recording. Okay. Now, we are discussing about Otto cycle. The Otto cycle is thermodynamic cycle that explains how internal combustion engine convert chemical energy from gasoline into motion. This four-stroke cycle involves four internally reversible processes. Process 1 to 2, which is isotropic compression. 2 3 is constant heat is added at constant volume. 3 and 4 and isotropic expansion. 4 and heat is rejected at constant value. Now, in this, we see the 2 and 3 here. It is constant value. Is a constant value for an is constant value. The Otto cycle is an ideal thermodynamic cycle that requires four-stroke with a piston, intake, compression, ignition, and exhaust. The fuel and air mixture compressed and electric spark needs it. The sudden expansion pushes the piston, producing a power stroke, and spring action of the piston pushes the combustion gas away. Now we see advantages of Otto cycle. The cycle are most commonly and reliably used in many IC engines. This extensive application should back up with some advantages. Good reliability with performance. The cycle is most suitable for lightweight vehicles that runs on petrol engines. Low cost manufacturing the engine based on the cycle. High power to weight ratio engines designed with the Otto cycle theme. Now we see diesel cycle. The diesel cycle is a representation of the combustion process that takes place reciprocating internal combustion engine. It is one of the most frequent thermodynamic cycles that can be found in automotive engine. Diesel engines are considered the directed application of the diesel cycle. Hence, let us understand the cycle in the context of the diesel cycle. Now, diesel cycle working principle. The piston, the crankshaft, the combustion chamber are three crucial components we need to comprehend the grasp of the fundamental working of compression ignition engine or diesel engine. Let us refer the animation about the stand. There are four processes involved in typical diesel engine. First is suction, compression, expansion, and exhaust. Yeah. Diesel cycle thermodynamic process. An ideal diesel cycle involves four thermodynamic processes: two isentropic reversible adiabatic process alternate with the isochloric process, and one isobaric process. This concept is better understood with the previous section as a reference. Let us learn process with the help of pressure and volume flow diagram. Here, suction stroke. Now this is suction stroke. The first procedure that introduces air into a cylinder is suction process. The piston is a top-rated center TDC position, and a piston moves from TDC to BDC when air is introduced. The inlet valve is open during the suction operation. This is exhaust valve is closed. Now, A to B is a adiabatic compression. The compression is a second phase in which the air and fuel that have been introduced into a cylinder are compressed. The piston is positioned at BDC. Throughout the compression operation, both the inlet and exhaust valve are closed. The piston moves from PDC to TDC during the stroke, increasing the pressure and temperature. Now, expansion stroke. This is expansion stroke. Means power stroke. This is the third step of the piston's position at the TDC. The piston moves TDC to BDC. The combustion fuel occurs towards the end. This is expansion. Now, the combustion fuel occurs towards the end of the compression process. The pushes the piston to the bottom dead center. During this phase, the intake and exhaust valve are closed. And after exhaust stroke, during the exhaust stroke, the piston at the PDC, the cylinder discharger charges out of the engines via exhaust port. During this operation, the inlet valve will be closed while the exhaust valve will be open. Advantages of diesel cycle. Now we have understood the diesel cycle process and compared the difference with the Otto cycle. Let us learn benefits of diesel cycle exclusively in this section. The efficiency of diesel cycle is higher when compared with the Otto cycle. The fuel costs are low, which is economic. Minimal change of the catching fire as the flammable fuel. Flammable vapors produced in the negligible amounts. Diesel engine have cleaner exhaust emission, which is less harm to the environment. Now Rankine cycle. The Rankine cycle is an ideal thermodynamic cycle involving a constant pressure heat engine which convert heat into mechanical work. The heat is supplied externally in this cycle in a closed loop which uses either water or any organic fluids as a working fluid. A simple illustration of this connected to the turbine and power plant draw electricity. Here we see this cycle. The Rankine cycle is a theoretical cycle on which the power plant work. This cycle, which is basic principle of the steam turbine, is also known as modified Carnot cycle. The Carnot cycle is thermodynamic cycle that has maximum efficiency. The drawback of the Carnot engine like its difficulty to operate practically or to with superheated steam or overcome by this cycle. Components of the Rankine cycle. Okay, components of the Rankine cycle. Now here, first is pump. They can be centrifugal pump in industrial application. Water saturated liquid enters the pump and is compressed. After boiler. Boiler are generally heat exchanger as in thermal power plants. The compressed liquid enters in boiler to be converted to superheated steam. After the turbine here. The turbine or steam turbine are machines that uses pressurized steam to produce mechanical work. The superheated steam entering the turbine expand and rotates shafts to produce work which generate electricity. After condenser. This is condenser. Condenser has a set of tubes with a cooling medium surrounding it. The cooling medium may be air or water depending upon the placement of the power plant. Steam in saturated liquid vapor states is condensed at constant pressure and heat is rejected to cooling medium. Now, working principle of Rankine cycle. The study of components of the cycle helps understand that the cycle operates in the closed loop where the working fluid is reused. Let us consider Rankine cycle. PV diagram, TS diagram with it. Working to understand working. Okay. A typically Rankine cycle has four thermodynamic processes, which are explained below, referring the all diagram. These diagrams. Now, let us assume that cycle is operating at temperature ranging from 0 degree to 400 degrees Celsius. Process 1 to 2. The working fluid entering the pump is pumped from the low to high pressure. This also is isentropic compression. The input energy is needed at this process process 2 3. Liquid at high pressure entering the boiler is heated by an external heat source. At a constant pressure, the liquid is converted to dry saturated steam by the constant pressure heat addition in the boiler. Process 3-4. The dry saturated steam from the boiler expands as it enters the turbine. It also known as isentropic expansion. Due to temperature and pressure of the steam decreases. Process 4-1. The wet vapor entering the condenser at this stage, it condensed at a constant pressure. It is it is then converted to saturated liquid. This process is also known as constant pressure heat rejection in the condenser. This saturated liquid is again circulated back to pump and cycle continues. The heat rejected or exhaust heat after the final stage represented as Q out. Thank you.